Hey, good morning, everyone. I'm actually very fortunate because I get to work with what we call emerging technologies, so I get to play with all the new and exciting things. And I wanted to share a few things with you, and I also brought some toys with me. I got some Raspberry Pis and robots, and we're going to do a few cool demos with that. And I think if you look out, there are a few emerging technologies, and one big emerging technology is very much the space of artificial intelligence. It's based on machine learning. Machine learning has been around for a long time, but over the past 2-3 years, we really saw an explosion of so-called deep learning, machine learning models. And they enabled us to do things that weren't easy to do before and get a lot easier to do right now. And I wanted to start off with one of the use cases that we continuously hear about, computer vision. What you see here, for example, is a video of a car that drives through the streets of Beijing. And it actually runs a machine learning model, an AI model, on that car. It uses a camera, and that AI computer vision model will basically try to identify the objects on the street. Here we see the people, we see the cars, we see the tricycles. Some of you in the room might be able to read the Chinese characters. It actually classifies the cars. So here's a Volkswagen, for example. And the way this is done, by the way, this is a video that was recorded by a company called TuSimple. They basically use cloud computing to train based on thousands of hours of video recordings and millions of pictures to identify objects, identify people, identify cars. And after training that model, they push that model out to the edge location being the car here, and then they run that model. Why do they do that? Well, this basically allows us to build autonomous vehicles. It's the baseline of building autonomous vehicles. Now, a single camera will not make a car quite self-driving yet, but these are the fundamentals that we're using for assisted or autonomous vehicle driving. Now, if you look at some of these machine learning models, and specifically those deep learning models, one of the factors that has contributed to continuously make that easier for us is some of the frameworks that are out there. You might have heard of frameworks like TensorFlow, which was released by Google, MXNet, Caffe and Caffe2, which was jointly developed by Amazon, Facebook, and open source developers, the Microsoft Cognitive Toolkit, Torch, Keras, a great UI that you can put on top of some of these deep learning, or I should say, these kind of AI engine frameworks. And we want to make it easy for you to say, if you want to build a model like the one you just saw, I want to use computer vision, I want to identify people, I want to train my own model, with a click of a button, we can do that. We have an AWS Deep Learning AMI. If you're not familiar with AMI, it stands for Amazon Machine Image. So with a click of a button, you say it launches a virtual server, comes with all these toolkits installed, comes with all the right dependencies and libraries. And the libraries are really important because some of these libraries, like the Intel Math Kernel library, for example, accelerate some of that deep learning inference even on CPU by a factor of 100 times potentially. Now, if you say, okay, that's great, but I actually don't want to train my model quite yet, I'm not ready for that yet, well, then we have a variety of services, and those are the ones that we want to focus on today, that allow you to do certain capabilities with just an API call. We bucket them under the concept of Amazon AI, which is some of these services that use deep learning under the hood to deliver functionalities like lifelike speech or conversational engines, or the ability to recognize people, the ability to perform image analysis. And these are services that we continuously train with data points, continuously improve it, but for you it just means that you need to make one API call against that service to actually get an inference, a prediction out of it. Now, if we take the example of Amazon Polly and Amazon Lex, Amazon Polly allows us to render lifelike speech. Amazon Lex allows us to have a conversational engine, natural language understanding, and automatic speech recognition. These are technologies that Amazon has been working on for quite a while. So you might have heard of a device called the Amazon Echo device. The Amazon Echo device is basically, you see the device right here. It's a device that has both a speaker and microphones installed into it, and it allows us to talk to the Alexa voice services. If you haven't heard of the Alexa voice services, it's basically the ability to use your voice to naturally interface with, in this scenario, you could call it an assistant. But it also allows us to extend any kind of capabilities around what that voice assistant can do, and that's what we want to have a look at today. The way on how it works, it actually listens for a wake word. So if we say a specific wake word, it will listen to us. We can then make a query against Alexa, like, what's the time, or, Wikipedia Singapore, etc., and it will deliver the results back to us. The default wake word is Alexa, but if I got some Star Trek fans in the room, you can change that default wake word to computer. So you can say computer, Wikipedia, this or that. Let's have a look on how that works. I actually brought an Echo Dot with me, which is the smaller version here. Alexa, say hello.
Hello.
Alexa, how are you today?
I'm excellent. I've got dinosaurs on my mind. If I was around back when they roamed the earth, I wonder what they would have asked me. Maybe, Alexa, what's that massive fireball streaking across the sky?
So we recently made a change to change that message every day. So whenever I present this, I get to what is she saying? That's so interesting. Alexa, where are you right now?
I'm here, and my head is in the cloud.
Her head is in the cloud. Now that's a good thing, because it allows us to actually extend the capabilities of what the Alexa voice services can do for you. Specifically for us, and I might have some developers in the room, we can actually create what is called Alexa skills. So the ability to actually have Alexa talk to your backend, your service, and deliver something back. And anyone who uses these voice services can now enable that skill to get a service from your company. So for example, I can book an Uber using Alexa. I can get a coffee from my local Starbucks with Alexa. I can order a pizza using my voice. How difficult is it to build something like that? I figured, it would be fun to show you in a quick live demo on how we could build such an Alexa skill. So the way it works is when we create an Alexa skill, it will talk to a certain backend. Think about it like a web server that it talks to. One place that we can do that is with the serverless concept. I can run my piece of code, for example, in an AWS Lambda function, and then extend the capabilities of what Alexa can do. So I figured, wouldn't it be fun if I connected to another open API, like, for example, Facebook? So what I want to do now is I want to use the Facebook Graph API to read out messages for my Facebook page using my voice. How would I do that? Let's just switch over to my laptop quickly here. First thing I need to have is a Facebook page, and I actually created one here. I called it the webhook demo page. And then the next thing that you can do is you can actually create a developer's account with Facebook, so on developers.facebook.com. You can sign up, you can create an app, and I created an AWS Lambda demo app here. And that app allows me to programmatically access the Graph API of the Facebook page that I tie this back into. The next thing that I can now do is create an Alexa skill that just connects to that API and reads out the messages for me. Let's try that out. I'm going to post something here as myself. Whoop. Hey, everybody. How are you doing? Always good to be back in Singapore. I used to live here previously, and so it's always like coming to my second home. All right, let's post this out. Now what happens, I send it to Facebook. Facebook, and the backend, I use the webhook that basically talks to my Lambda function. I can read or store that post, and now I can actually go ahead and use my voice to read it out. Alexa, ask LambdaBot about new Facebook posts.
Olivier Klein was writing, "Hey everybody, how are you doing? Always good to be back in Singapore."
Cool. Right. Now, since this is public sector, I went ahead and said, could I create another skill, something that is very dear to us when we're in Singapore? Air pollution, right? Data.gov.sg is publishing some, and some of you guys are posting now on the page, which is great, are publishing some great APIs. So I created a quick skill. Let's see if that works. Alexa, ask Singapore data about the current PSI.
The PM 2.5 reading in Central over the last hour was 15 and 25 in the South, with an average of 20.
Good, so we can go out for a run, right? Let's go back to the slides, please. So the capabilities here can be extended to whatever we want to do, and that's great. So we have not only a smart assistant that is limited to what Amazon might program in here, but we can extend those capabilities. Now the underlying technologies here are a few, and we actually make them available as an API functionality for you to build your own systems or services that can not only understand and recognize speech and build a conversational engine, but also render lifelike speech. So for example, when you listen to Alexa, there are different kind of voices under the hood that we are rendering. And then you want it to sound natural. And we're actually using deep learning techniques with natural language understanding when we render a certain sentence. I'll give you an example. If you make something like, "Hey Singapore, how are you doing today? Am I in Singapore?" Or you say, "Are you in Singapore?" or "I'm currently in Singapore." The intonations vary based on the context that you're having. So one service that can help you do that, to synthesize voice with different languages and different kind of voices that are available, is a service called Amazon Polly. So if you need the ability to render voices that sound natural, Amazon Polly can do that for you. The other underlying element is a conversational engine. She needs to understand what I'm saying. She needs to have automatic speech recognition, but also natural language understanding to understand my intention of what do I want to know, what do I want to do. So if you want that capability, you can actually make use of Amazon Lex, which allows you to build these conversational interfaces, both spoken, was what we just saw here, but also written. So it's a great kind of service that would allow me to create a chatbot functionality. Facebook recently released, I think it's been about a year, the capabilities to create chatbots in the Facebook Messenger. Attach it to your page, and then have your end user and customers actually interact to the Facebook page. With Amazon Lex, I can easily create a bot like this that would allow me, in this scenario, for example, book a hotel, but this could be anything. Find out when my branch is open. Find out what do I need to do to renew my EP. What do I need to do this or that. Those are kind of conversational interfaces that generally are handled to a customer service hotline that we can now, to some extent at least, automate to both this customer service hotline because it's spoken, but also written through the chatbot. Again, I like to show that in a live demo because it makes it a lot easier to understand what does it actually mean for me. So what if I want to create a certain bot? In this scenario, let's say I'm a bank, I want to allow people to apply for a credit card to my Facebook Messenger. Well, all I need to do is I use Amazon Lex, I create an intent that is, for example, apply for a credit card, and then I can say publish that to Facebook. And I can also say whatever happens, that conversation is being held by Amazon Lex, but the outcome should be sent to my piece of code. Where do I store my piece of code? Well, AWS Lambda is a good place to store that. So in my piece of code in AWS Lambda, I'm going to take that application, put it in a database. I chose Amazon DynamoDB, and I'm going to notify my operations team via message to my Slack channel. Let's have a look on how that would work. So let's switch over there. Perfect, thank you. So the first thing that we need is actually Lex. And the other thing is obviously another Facebook page, which I created here. I called it the demo BankBot. Now, if we look at Amazon Lex here, we can actually create what is called a chatbot. Let me just open this up correctly here. There you go. We got our credit card application chatbot here. And what we do is we actually create different sample utterances. So if a person says something like apply for a credit card, get a credit card, receive a credit card, he doesn't need to literally say that. Even if you say something like I want a credit card or credit card can, also should work. I haven't tried it, but should probably work because the intention is the same. And as soon as that happens, well, then it would jump into that intent. So it tries to fulfill those intents. We can help multiple intents, as many as you want, and then define sample utterances. If somebody says something along those lines, this intent should be fulfilled. How does this intent get fulfilled? Well, we basically potentially want to ask some additional questions like, what's your name? Which city are you from? What's your phone number? If we want that to happen, we can create these slots associate a type with it, and associate a prompt with it. So now Alexa will try to fill in this information by having a conversation with me, and when I'm all the way done, I can call out my own piece of code function through an AWS Lambda function to deliver this. Let's try this out. I'm going to go to my bot here. All right. I actually haven't tried this, so this will be fun. Let's see. Yes, it worked. Awesome. So, okay, what's my name? Okay, my name is Alvin Klein. Great, okay. What city do you live in? Well, actually, I do live in Hong Kong now. And so it will try to fulfill those slots. What's your phone number? That's my phone number. There you go. And obviously, because the slot is not fulfilled, this is not an actual phone number, it will tell me, no, that's not right. Give me the right phone number. Okay, so how about, this is not my actual phone number now, so you don't need to call. Here's the phone number now. Okay, that's good. What's your birthday? You know, I as a developer would love people to do the following, right? When was the last time you saw someone enter his birthday like that? Not really, right? So the other good thing about slot verification is even if I type something natural like this, it will actually bring it back to the format later that I want as a developer. Okay, what do I have? Okay, I have a master's. Thank you for that. There we go. Shall we submit? Yes, please. That's good. So we now fulfilled all the slots that we needed to fulfill. Thank you, Alvin Klein, for your interest. We will get back to you soon with the next steps. And you already heard there's now a Slack message that came through from my credit card application bot that now basically passed that information into something that I can make use of, immediately have my operations team use it, and in this scenario, this will also be stored in my database table. All right, great. Let's go back to the slides, please. So great ways to quickly create conversational bots. You saw the interface. I typed a few messages in. I just say publish the bot to my Facebook page, and that's it. I now have a conversational interface that I can use. And by the way, it's not limited to Facebook. Everything is a web service. That's why we call it Amazon Web Services. So everything is an API. So if you want that functionality anywhere, like in your website, for example, you can totally achieve that using an API call. So we talked a lot about voice. How about vision? So there are interesting elements around classifying, understanding images, recognizing people that we see more and more actually being used in actual applications. So for example, visual recognition, I mean, we just saw in the latest Apple release, for example, that's something that we continuously do. I live in Hong Kong, just next door is Macau. Macau, the financial regulator, for example, now makes it mandatory for any ATM machine to have facial recognition. So this is a technology that will become very natural to our lives. Now, one element of that is, again, we want to make that easier for you to actually have that visual understanding of assets that you're having, like pictures of people, but also pictures of different goods. So Amazon Recognition allows you to do that image recognition, facial detection, people recognition and analysis, powered through some of these deep learning algorithms that we use under the hood. So what can you do? You can take a picture like this, you upload it, or you send it, I should say, you send it to the Amazon Recognition API, and it will give you back, okay, what do I see in this picture? Okay, with a certain accuracy, I think this looks like a swimming pool, this looks like a maple tree, this looks like a backyard, this looks like a villa, etc., maybe a garden. So it allows us to classify images based on what we see within that image. That can be very useful, for example, to have certain verification processes. So one of the companies I work with uses this to actually identify, is a person uploading a correct profile picture? Is it a person or a selfie, for example? And if it is, move it forward, make sure it's moderation, recognize if it's a celebrity, because it also has celebrity detection for it. And by the way, it works with Singaporean celebrities. All right? I actually tried it out, and you had like a Gurmit Singh, yeah, recognizes it, awesome. All right? Good stuff. But it allows me to classify these kind of images. It also allows me to identify faces. And when I identify faces, it also allows me to perform a certain sentiment analysis, like, is this person smiling? Is this person happy? Or is this person having a mustache or a beard, for example? Or some general attributes like, Are his eyes open? Now, it's always the best explained if we actually take a live demo. And so I encourage you to participate in this one, because I built a little serverless website, and it's also mobile friendly. The URL is code4.cloud/image. So if you want to follow along, you can actually type this into your mobile phone. And what it allows us to do, it allows us to actually upload a picture to our serverless interface. It will be sent to Amazon Rekognition, and then we will see the results. Now, I did not put in a moderation filter, so please do me a favor, only upload decent pictures, because I'm going to flash that up here now. So let's just switch over to my screen here. So the URL, just typing it in here one more time, code4.cloud/image. And it will bring us to this interface. It's serverless, comes straight from an S3 bucket. It's mobile friendly, so if I go ahead and do this, you can see we get this little burger bar here using Bootstrap to do this. Fantastic. So how about I upload a certain picture? Try it now. Olivier, and I choose a picture. It can be one of your face, but can also be any kind of different picture. So for example, I have a picture of Hong Kong here. Let's try this one here. I haven't tried this one for a while. This is a wonderful nice little temple in the lake next to Kaohsiung in Taiwan. Very nice place, can recommend to go there. Let's upload this. And this will send that picture to an Amazon S3 bucket. That S3 bucket will pick it up. It gets an event notification. Hey, there's a new picture available. It will then send it to Amazon Rekognition. Amazon Rekognition will try to understand what it is using those deep learning, machine learning algorithms. And then if I go back to my image wall, I should now see that this is slowly coming true. So for example, this was detected as pagoda. We have some people coming true, some furniture, myself here came up. And I see this is wonderfully working. So we have faces also being detected here, faces behind. Here, brochure, flyer. Sounds about right. Awesome. Poster. Not quite a diploma yet. That's AWS certifications. And light fix, lightning. So you see, as you start uploading pictures, it slowly starts to understand what's going on. I like this one. Table logo, coffee table. Very nice, very nice. And if it detects a face, this one is nice. Whose car is this? You're a lucky guy. That's a nice car. Perfect. And if it detects a face, I can obviously, in my piece of code, go ahead and actually crop a face out. So if you click on Face Catalog, we actually see that, some people are coming true. Some are a little bit sad. I hope I don't make you too sad. But overall, it seems rather happy. And some of them are a bit surprised. So this is fantastic examples that you putting up right here. There you go. Keep calm and cloud it better. I like that one. Very good, very good. Awesome. Thank you. Let's go back to the slides. Thank you very much for your participation. Really appreciate this. So this is a good example of the power of two concepts, actually. The first one is a serverless architecture here. Because basically this would scale to any kind of size of people in the room, because we use things like AWS Lambda, API Gateway that automatically scales out to all your uploads that you're doing. But it also illustrates the power of using pre-trained deep learning machine model, such as, for example, Amazon Rekognition, to identify, classify faces, classify pictures, etc., and get a better understanding of it. So now comes the fun part. What if we bring this all together into a live demo? So I brought with me a few toys. I brought with me a Sphero robot, and we get the camera set up in a bit so I can show that to you. The Sphero robot here. Sphero is, this is the SPRK Plus robot. A little bit of a toy robot, translucent kind of toy robot that generally used as a toy. There's another version called BB-8, which was the Star Wars version, very popular. We can roll that around and we can control it using Bluetooth. So I figured, let's do something cool. Let's see if I can actually enable some AI around that robot by connecting it to my Raspberry Pi, connecting it to AWS IoT, so that I can talk to the robot through my cloud computing environment. Then I can do a few things. I can use my voice to talk to the robot, maybe connect it to the Alexa voice services, maybe have the ability to actually make it change its color, roll around, or, and that's the last part of what I want to demonstrate, is could I make it recognize objects, right? Could I make it recognize certain props? So with me, I brought some bananas and some Coke cans here. That's good stuff. So how about I try to build a robot that allows me to actually go and find these kind of objects. All right, so let's have some fun with this. Let's switch over first to my screen here. Perfect. I got the camera too. So what I'm going to do first is I'm going to power up this robot here. Let's come up. Let's bring this guy down here. Power him up. There you go.
Hello.
Hello. There you go. So what you see here on the screen is actually my console of the Raspberry Pi. It's using AWS IoT to connect to my cloud computing environment, and it's using Bluetooth from this Raspberry Pi to control the robot. So one thing that I can do is I can, for example, roll around. I can say,
Go, go, go.
can say here, roll around. Making it difficult for Patrick now to follow me along, but we can
Go, go,
control
go.
this robot around. Obviously, you can have different languages. Good. How about? There you go. And we also got obviously collision detection on this robot. So if I were to take this robot and kind of throw him around, she's probably not so happy me doing that. Cool, right? So now I have a robot that I basically have connected to my cloud computing environment. So the next thing that I can do is, because it is connected, I can now make use of these API calls to these machine learning services, and I can also integrate it with the Alexa voice services. Let's have a look at that. Alexa, ask Sphero Robot to change its color to red. And there we go.
I changed Sphero's color to
Sphero's
red.
color to red. Let's try this one more time. Alexa, ask Sphero Robot to change its color to blue. We'll talk to my backend.
I changed Sphero's color to blue.
Update IoT shadow state, and now we can actually use our voice to control the robot. Let's try one more thing. Alexa, ask Sphero Robot to perform a stunt.
Sphero performs a stunt now.
Very cool. My Sphero performs a stunt. So now we have the capabilities with a few API calls and things like AWS IoT to use my voice to actually control a robot. So that's pretty cool. So the next thing that I want to do is I want to see, could I actually use the components of Amazon Rekognition to make it recognize objects and understand what it's seeing, and then actually navigate the robot to those objects. So what I want to do is, I'm going to have some bananas here. I'm going to put them on the stage. Get some cans of Coke. Let's put this, for example, somewhere here, up here. And I want the robot now to go ahead and actually find those objects. When should it find those objects? Well, it should find those objects when I actually do see them in my webcam here. So I have my webcam here, and this is using JavaScript in my browser. We'll take pictures of my webcam, send it to Amazon Rekognition. It will identify what it is, and if it's a banana, we'll tell the robot to go find it. It's a Coke, we'll tell the robot to go find a piece of Coke. So the first thing that I need to do is, I just need to... It's okay, it's okay. Let's change this around. And I just need to calibrate my robot so that it has the right kind of boundaries for this. It's okay, it's okay. We go. She doesn't want me to calibrate her. And the idea here is, obviously the robot needs to have an understanding of the stage. So I'm calibrating her and say, you are now in this position. So that's good, because now it knows where objects are lying around, and I can go ahead and actually find them. So let's see if, just make sure that I get this correctly done here. Perfect. So the first fun thing that I could do is, as my other banana, there you go. I could take a banana and show it to, I gotta start recognizing objects first. There you go. It now it takes pictures of my webcam, and you see it now starts identifying that with Amazon Rekognition. So next thing that I could do is I could show a banana. There we go. My robot finds the bananas. I can now go ahead and show him maybe a can here. There you go, and it finds the Coca-Cola. Let's try this out. This wasn't just a little trick. There we go, and we go back to the bananas. So a wonderful little way of using some of these technologies. Thank you very much, Patrick. So like I mentioned earlier, I think my manager always says, I think you got the coolest job in this company. I get to play around with toys like this, and it's fantastic. Now, I want to leave you with this. I mean, probably nobody's going to go ahead and build his own Sphero robot unless you're a little bit of a geek like me and want to spend too much of your free time on things like this. But there are certain interesting concepts that we looked at here, right? The power of having an API call that we can make and get access to some of these deep learning machine models, get access to scenarios like using our voice to control animate objects. Those are quite powerful. And you know, if you're interested how this works, drop me a note. I can actually send you the piece of code. It's just only a few hundred lines of code. It's very simple to actually build something like this. Build kind of applications where we now can use our voice to talk to applications, write to applications, build chatbox functionalities, use computer vision to understand, you know, who is talking to, find different objects. And we're only scratching the surface. There's a lot more to come from both our partners, from Amazon itself. So stay tuned in that regard, and I hope this was insightful. Thank you very much for your attention.
Big round of applause.